Welcome once again. This is Turning Point Tutorial. We have to make a kind of progress to the next stage. Today we are looking at kind of a continuation of what we had in last class. Here we are looking at the calculations on equations of linear motions, equations of linear motion. There are different calculations that are there. Well, we have various questions to consider: question 1, question 2, question 3, question 4, and even more. But let's look at the first 4 here. We have to consider this first one here. A body starts from rest and accelerates uniformly at 5 meters per second square until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. This is NECO 2005 question, a question from NECO 2005. Let's always remember, when you are making your calculations clear, or if you want to make it so clear and nice, you will need to start by writing the parameters. Start by writing it. You write the parameters. The question is, what are the parameters? Now you need to consider some of them here. Like you were given velocity 25 meters per second, you were given acceleration 5 meters per second square. You know quite well that whenever you hear meter per second square, your mind should go to acceleration, whether acceleration or retardation. Now we also see 25 meters per second, that is for velocity. But there are some things we need to consider. Like I said last time in the former class, we must remember that when a body moves from rest or starts from rest, comes from rest, then we should know what we need to ask ourselves here. What should be equal to 0 initial velocity? When a body comes from rest, u, which is the initial velocity, is equal to 0. And when the body goes to rest, then v, which is the final velocity, is equal to 0. Let's look at it this way. Let's start now from the very first one here. Start by writing down the parameters. Let's see the solutions. A body starts from rest. That means u is equal to 0. That's the first step, one of the parameters. And accelerates uniformly at 5 meters per second square. So a, which is acceleration, 5 meters per second squared. Then the next one, until it attains a velocity of 25 meters per second. That is the final velocity, the new velocity. It attains a new one, which is v equals what? Equals 25 meters per second. Then look at it again here. Calculate the time taken to attain this velocity. What's the question? What's the question now? The time taken. What's the time taken to attain this time? We don't know time t. Let's have a question mark there. U is equal to 0, A is equal to 5 meters per second squared, V is equal to 25 meters per second, and the time is a question now. What's the time? What's the time? Remember, we need to recall, just always try to recall the equations of motion, the equation of linear motion. We have to know here, recall that V is equal to U plus AT, and that S, the distance or displacement, is equal to ut plus half at squared. Then we also need to remember these two. V squared is equal to u squared plus 2as. Now consider what we have here. The first equation of motion, consider it here that the parameters u, a, v, t matches with this one. So we're going to make use of this. V is equal to u plus at. Now it implies that V is equal to, which is equal to u plus at, will be used. Looking for the time, we have to make time the surgeon formula. Therefore time is equal to V minus u plus V minus u all over a. What's the time? What's the velocity? The v, final velocity, that's 5. That's 25. Then the u, which is 0, all over a, and a is 5. That gives me 25 all over 5, and that's equal to what? 20. That's equal to 5. 5 seconds. Therefore, the time is equal to 5 seconds. And that is a question, a Y 2005 question. Now let's consider the second one, a car. A car. This one is from UTM in the JAM question 1, that's 1990. A car moving with a speed of 90 kilometers per hour was brought to rest by the application of brakes in 10 seconds. The question now is, how far did the car travel after the brakes were applied? How far did the car travel after the brakes were applied? And you know the option A, 125 meters, B, 150 meters, C, 250 meters, and D, 15 kilometers. Let's look at it very well. The first thing I said before, we always do write out the parameters. And what are the parameters? Speed of 90 kilometers per hour. A car moving with this, that means the initial velocity, the initial speed, 90 kilometers per hour. And then there must be a final speed because it was brought to rest. And since it was brought to rest, it was moving to rest. Therefore, V, which is the final velocity, will be equal to 0. Remember I said before, a body going to rest, moving towards rest or retarding, is actually having final velocity equals 0. Then we need to move forward and write our parameters. The question is, what are the parameters? The first parameter to take down here is the initial velocity. A car moving with an initial velocity, initial speed, sorry. So the initial speeds, and you know speed and velocity have the same units, and so as well the same symbol. So here we can say U is equal to 90 kilometers per hour. And since you know quite well that the answers were given to you in meters, so we need to make a conversion, convert the kilometer per hour to what? To meter per second. So we need to do a kind of conversion. And what's the conversion? 90 kilometers per hour means 90 times 1,000 all over that per hour. 1 hour means how many seconds? 3,600 seconds. Now go ahead now. We say the 0 cancels the 0 and this one cancels the 0. And then what we do right now to say we have 90 into 9 into 90, that gives me 10. 9 into 36, that gives me 4. And then we have to say 10 times 10, that means we have 10 times 10 over 4. And then we have 2 here, 2 and 2 is 5, and 2 here, that's 1, and 2 here, that's what? 5. 5 times 5, that gives me 25. 25, that's 25 meters per second. That's now the initial velocity or the initial speed. Now we move to the next parameters. To rest, since the set was actually moved to rest, the car was moved to rest, final velocity V is equal to 0. In the next case, now we can say the application of brakes. This brake was applied in 10 seconds. So the time now is 10 seconds times T is equal to 10 seconds. Then in the next case, we have how far did the car travel after the brakes were applied? How far did the car travel after the brakes were applied? How far? That means the distance. Now you can say distance S is equal to, we don't know about that. Now we look at it very well. Remember that at different times when you are given a question, you will know what is needed and what is required. What do you need to actually solve the question? Now consider the equations of motion. You have to recall right here that V is equal to U plus AT, and that also S is equal to UT plus half AT squared, and that V squared is equal to U squared plus V squared equal to U squared plus 2AS. There are two different ways. If you want to make use of any of this formula to start, you know quite well that in all this formula, what is common in all these three formulas what we have here as common is A. Acceleration is here, acceleration is here, acceleration is here. So if you want to get something like distance or time, you want to calculate for the distance or time, and acceleration is not given, you need to go forward first and look for the acceleration. If you must make use of any of this formula to get the distance, then go forward and look for the acceleration. Since there's no acceleration given to you here, consider it very well, no acceleration. So what we're going to do right now, look for the acceleration. Then after that, then you make use of any of the formula that matches with the parameters to get the answer. But if you don't want to go through this method, then you use the other way around, which is, what's that now? Remember I said before that in previous classes we had a kind of derivation, and that's distance S is equal to U plus V all over 2. U plus V all over 2. Distance, remember, U plus average velocity times time. That is average velocity times time. That's what we had before. And then we can make use of these two. Recall this one also. Either these three, if you want to make use of this or use this. Now let's make use of this and get the answer very fast, quickly, and see what is obtainable. Now it implies here that distance is equal to U, initial velocity, which is what? 25 meters plus final velocity 0 all over 2 in bracket. Time, what's the time? Time is 10 seconds, so times 10. At the end of the day, what do you have? 25 over 2 times 10. Then 2 here 1, and 2 goes into the 10, that's 5. 5 times 25, that's what? 125 meters. Therefore, the distance is equal to 125 meters. That's the answer to the question, and that's what we have here. You have A as the answer. A is the right option. Now, if you are to make use of any of these, to start with any of these, then what you need to do, look at what is required. You ignore this S first and look for the acceleration. Look for the acceleration. How can you look for the acceleration? Make use of V, A, U, and T. Make use of V, A, U, and T. V, A, U, and T. It means that you make use of V is equal to U plus AT to get your acceleration. Then from the V equals U plus AT, you make your A the subject formula, and then you will get the acceleration. After that, you can now move forward and make use of this equation 3. V squared equals to U squared plus 2AS to get the value of the distance traveled or the distance covered. That's what you can do. So you also can try the other way around, you get the same answer too. Then the next question, what's the next question? Number 3. This is from JAM question UTME 1992. And they said the body starts from rest and moves with uniform acceleration of 6 meters per second squared. Then the question is, what distance does each cover in the third second? What distance does it cover in the third second? This is very important. Let's consider it now, very, very quickly. Let's consider this one very, very quickly. This is the kind of question that we need to work out with wisdom. It's not too hard. It's straightforward. But we need to consider the statement here. What is the statement? A body starts from rest. Initial velocity U is 0 and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third? Whenever you hear the word third second, fourth second, fifth second, last 1 second, the third second, the second second, you see here, you have to understand that at this very point in time, we have to adjust some of our parameters. The time parameter must be adjusted to fit in very well. Listen, if you want to start this right at the parameters as usual, first of all, U is equal to 0 because it's from rest. And then the next question is, when you say, okay, U is equal to 0, acceleration is given. What's acceleration? Acceleration is what? 6 meters per second squared Then the next one, what distance does it cover in the third second? Now the time, third second. The question is time, which is equal to, if you say 3 seconds, then you are wrong. You are wrong. In the very case, time cannot be equal to 3 seconds. Now, when you say third second, you go to adjust it this way. The time, to make it easy to abbreviate everything and get the answer straightforward, the time becomes equal to time, the third time, minus the second time. You find the difference between the third time and the second time. So here, the time now will be t3 minus t2, the third time, the third second, minus the what? Second, that is the third and the second, the third and the second, the difference. T is equal to t3 minus t2. We said, what distance does it cover in the 10th second? What's the time? T is equal to t10 minus t9. Then they ask you what distance does it cover in the 15th second. You say t is equal to t15 minus t14. I believe you got that t14. I believe you're following up. This is a principle to apply, to make it very fast, to make it so quick. And then you go ahead now. Now you understand here that nothing was said about the final velocity. We have it here that it actually was coming from rest, start from rest. So you need to know, you were asked to find the distance. What's the distance? Distance, we don't know. Now you have, what's this now? You have UATS. SUAT, SUTAS. That means now you have to consider that from the relation. That's what we need to look at now. What's the relation? Which formula can we apply from S equals UT plus half AT squared? Now look at it very well. You can see here that this what actually matches the parameter. S. Here, there's an A, there's a U, there's a T, and then we can use this. What we need to do right now, substitute into the formula, and then you make the S. Okay, this side cancels out when you have S, which is U equals 0 times time plus, and then what's the next thing now? Plus half A, what's my A, the acceleration, and that's what it's 6 times, what's the time? Open the bracket, you have the time now, it's going to be t3, t2, so you have t squared, that means t3 squared minus t2 squared, like this. Then it implies here that the distance traveled 0 times t, that cancels out, becomes half times 6. Now the time t3, it means that the 3 we need to replace the t. T2 means that the t have to replace it. The 2 will need to replace the what? Represent the t. Then you have it this way, times 3 coming in here, you have 3 squared minus 2 replacing the t, you have 2 squared. Close the bracket. Then you have, it implies that distance is equal to half times 6 times, then you have this 9 minus this is what, 4. At the end of the day, you will have half times 6 is going to be 3. This cancels out. That's 3 times 9 minus 4. That gives me what? 5. So this is going to 3 times 5. That's 15. So it implies that distance is equal to 15 meters. Distance is equal to 15 meters. So that means the option here is A. The right answer to the equation is A. 15 meters. Then a car starts with the next question here. A car starts with a constant velocity of 45 km per hour per 1 hour for 20 seconds. The question is, what distance does it cover in this time? What distance does it cover in this time? So we can see here, right now we move forward to this aspect and break it down. What distance does it cover in this time? That's the question. That's NECO 2005 question. NECO 2005 gave us this question, and we can say that write the parameters. That's the first thing to do. Usually, the first thing first are the parameters. Yes, we are given constant velocity. When the question is when velocity is constant, another thing we should always remember. Remember the first thing we said before. When the body moves to rest, v final velocity is 0. When the body is coming from rest, u initial velocity is 0. And then when a body is moving with a constant velocity, then a, which is the acceleration, will be equal to 0. Don't forget, a body moving with a constant velocity, the acceleration a is always equal to 0. Now, what we need to do right here is to write the parameters. Our a is equal to 0 acceleration. Then what about the velocity here? Constant velocity. And what's the velocity? Velocity v, we can say that's the initial velocity. Let's say v, or we can say u, is equal to what? To 45 kilometers per hour. Change it to second, to meter per second. You're going to have something like this. You have 45 times 1,000 all over, then 3,600 seconds. You come out here. What you have right now, you have 9 going here, you're going to have 4, and 9 going here, you're going to have 5, and then you have to say 50 times 4. That means you have our u value is equal to 50 over 4. That means 25 over 2. That gives me what? Give me 12.5 meters per second. Then for the other aspects, time. What's the time? Time is equal to what? 20 seconds. Then what we're going to do right now, what's the distance? What's the distance? That's the question. The distance. S. We don't know the distance, so we can say the a is there, the u is there, the s is there, the t is there. What's the equation to apply? It's equation 2 that actually matches the equation 2. Let's recall the relation. What's the relation? The relation here is what? S is equal to ut plus half at squared, and that means we'll say the distance. It implies here that distance is equal to, now you can say here that the a is 0. A is 0 acceleration. Now you're going to say u, what's my u? U is 12.5. 12.5 times, what's the next one now? That's time. The time is 20 plus half, and half times, what's the acceleration? 0 times the time t squared. So at the end of the day, distance is going to be 12.5 times 20. Everything here ends up to become 0 because the 0 is here. 0 times this and times this, 0. So at the end of everything, you're going to have what? Distance is equal to, now 12.5 times 20. That gives me what? That gives me 250. Then meters. That's the answer. Plus 0, and that's 250 meters. And then that's the answer to the question. Now we have seen these 4 questions, these first 4 questions, when we want to actually move forward to other questions. But let's not forget, there are other questions that have to do with forward, upward, and downward motion. Upward motion, downward motion. We will consider that from questions 5 to the end. Let's move on now. Now we consider the question 5 and then question 6. Now from question 5, an object, or I can say an orange drops to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? As WAEC 1991 question. Then in addition, I just want to add this one to it. Hence, calculate the velocity with which it strikes the ground. Then the other question, question 6. A ball bearing is projected vertically upwards with a speed of 5 meters per second. Then the question is calculate the time taken by the ball to return to the ground. Remember your g, your value, because it's upward motion, anything upward or downward, you must understand that the g value, there's the acceleration due to gravity, is always approximately 10 meters per second squared. That's WAEC question, WAEC 2004. But now let's look at it very well from the first question here. That's the question 5 here. An orange drops to the ground from the top of a tree 45 meters tall. Listen to this right here. The height, the tallness of the tree also has to do with the height. the height above the ground level. So the height above the ground level, the vertical distance, h is equal to 45 meters. Now here we also look at the other parameters, because it actually was resting, it was coming freely, falling freely from the top of the tree. That means here our initial velocity u is equal to 0. And then we are looking at this one that said we should find the time, or how long, that's the time. How long does it take to reach the ground? And that time t is equal to, we don't know yet. Now looking at it very well, our g, acceleration to the gravity, is equal to, is a positive one, because it's actually in the direction of gravity. The fall is in the direction of gravity acting towards the ground. So here we can say it's approximately equal to 10 meters per second squared always. Now recall, because it's a question that has to do with free falling body, the time for a free fall, the time to fall freely to the ground, and if it was fall freely to the ground, remember we have said something before. Recall that the formula for the time, the expression for the time for free fall, t is equal to square root of 2h all by g, and that is what we have as the expression for the time for a free falling body. And what you need to do right now, it implies that when you substitute t is equal to, and your initial speed is already 0, and so what we're going to do right now is to say square root of 2 times, now the height, vertical distance is 45 meters, all over, then g is the acceleration due to gravity, that's 10. That gives me what? 2 times 45, that's what? 90, and as all over 10. Now you break it down, 10 divided 90, that's 9. Now square root of 9. It implies here that the time is equal to what? What's the square root of 9? That's 3 seconds. 3 seconds, that's the answer to the question. Then the next question here, still in addition, hence calculates the velocity with which it strikes the ground. That's velocity for free fall. So all you need to do right now is to still recall that the velocity for a free falling body v is equal to the square root of 2gh. First, very quickly, we can now fix everything in. V is equal to square root of, now see to this right now, 2, what's the time, what's the g, 10, and what's the h, 45. Now 2 times 45, that's what gives me what? It gives me 90. 90 times 10, that's 900. Square root of 900. And what's the square root of 900? You must understand, it's just so simple. Now you're saying 9 times 100, and the square root of 9 is 3, and the square root of 100 is 10. So 3 times 10, that's 30. So the square root of 900 is what? 30. So it implies here that the velocity is equal to 30 meters per second. The final velocity with which it strikes the ground, is actually 30 meters per second. That's the answer to the question. And question 6. The question 6 here before us is, now a ball bearing is projected vertically upwards with a speed of 5 meters per second. The question is calculate the time taken by the ball to return to the ground. Remember, it actually was thrown upwards, projected upwards, vertically upwards, and then it falls to the ground. Now remember here that the time to move to the highest height is the same as the time to fall from the highest height to the ground level. So all you need to do right now is to find the time for falling from the highest level to the ground, falling or for moving upwards, from time to move from the ground level to the highest height. Which one is easier? The easier aspect is the one it's actually the time to actually move from the highest height and fall to the ground. So all you will do right now, just look for the time for free falling body, the time to move from the highest height and fall to the ground. And when it's moving from the highest height to the ground, remember u is always equal to 0. That is the initial velocity, always equal to 0. Now we still need to retain the same formula here. T equals square root of 2h all over g. Now to say t, recall that time t square root of 2h all over g. Now what's the time, what's the height? Now it says here, now it's a speed of 5 meters per second, was projected vertically upward with a speed of 5 meters per second. Okay, alright, let's see something now. The initial velocity was 5 meters per second, and then it goes to the highest height. Just make use of the other way around. What we have here is, let's write the parameters first. Very important. The initial velocity was used 5 meters per second, and then what is the acceleration to gravity? G is equal to 10 meters per second squared. Then what about our final velocity at the highest height? V is equal to 0. Our V is equal to 0. Then what about the other parameters? We have the time t. Time to reach the highest height, we don't know. What we'll do right now is to say, remember, as it gets to the highest height, remember that our V is equal to U plus AT, which now changes to, because in vertical motion, V equals, now at the maximum height, your V is 0, and then U is there, our value is there for U plus, then our G, A changes to negative G because it's opposed to the direction of gravity. Then we can say time. At the end of the day, plus and minus you have, it implies here that 0 is equal to U minus GT. Therefore, our U, our time, our U is equal to GT. Therefore, our time is equal to 5, that's a 5 or 15. Okay, let's say 5. Sorry, this question is 15. So let's say time, 15 meters per second. Then we'll say here that 15 all over the time is how many? What's the time? Okay, the G is 10. Now we can see we are trying to make our G, our T, the Taylor formula. We have T is equal to 15 over 10. That's what 1.5. The time is 1.5 seconds. Therefore, we say time to get to the highest height is 1.5 seconds. To get to the highest height, 1.5 seconds. Now, since time to go up, the total time, it implies that the total time, which is time to go up T1 plus time to come down, which is T2, and both of them are equal, then which is same as what? 2T. So therefore, the total time is now 2 times 1.5, that's 3 seconds. And this is the total time it spends in the air before striking the ground, and that's 3 seconds. So you should understand that it's straightforward. We can use it that way around, we can apply it from the, but I prefer we use this now, since the parameters that are needed for going up were given. So we have U, G, and V at the maximum height equals 0, and the time to get to the maximum height, which we have seen, which is 1.5. So all these are clear examples that will help us to kind of improve our solving skill in this aspect of physics. More of the questions will be coming at different times, and if you have any problem, any kind of question we should look into in this very topic, you can try it on your own, and then if it's anyone that is difficult, we're moving forward to us this turning point tutorial. We'll move on in the next class to the next aspect of the topic. Thank you very much.